So again, on your final exam, if you get a question like this, it would come with a formula. So the formula would be given, maybe it would be this one here. They would show you what the formula looks like, and then they would describe what each of the variables are. So our compound interest formula, A equals P 1 plus R over N to the NT. A is the amount after T years. P is your principal, or the amount that you're starting with. R is your interest rate. And the number of compounding periods. So if they say it's compounded monthly, then N would be 12. If it's compounded quarterly, then N would be 4 times a year. Compounded daily, then N would be 365. And then T is the time in years. So if we start this question off, we want to know to the nearest quarter of a year, when will the amount be 2,500? So we know that the amount is going to be 2,500. It's asking for to the nearest quarter of a year, so they're looking for T. So we should be able to plug in everything else except for T. We started off with 1,500. The interest rate, and maybe we should put in here that in this formula the interest rate is always as a decimal. So at 4%, that would be 0.04. It's compounded quarterly divided by 4 and to the power of 4t. Now, if we simplify our growth factor, that's this part inside the brackets. We get 1.01 to the 4t. Do we have 1.01 on our powers chart? No. So this is telling us right away that we are not going to be able to do this one using the techniques that we did before, where we got both sides to be the same power, and then with the same base, and then solve it from there. So we're going to need to use our calculator for this one. So we go to our calculator. What we're going to do is we are going to type this part of our equation into y1. So I'll write y1 and this side into y2. $2,500 into y1, 1,500, 1.01 to the power. Now, if you have the newer calculator that the power goes up like mine did right there, you can just write 4x right away. If you have an older operating system that the little hat thing comes up for the power, then you need to make sure that that's in brackets. Now, if you've got it on a standard window, this is what's going to show up. Nothing. Nice. And the graphing calculator is a very, very powerful tool, but it's not powerful if you know no math to go with it. So a couple things here. When you type in equations to graph them, you're probably going to have to change your window. And in order to change your window well, you need to know some things about the functions you put in. In y1, we put y1 equals 2,500. What kind of graph is that? Straight line. Going through what? Going through 2,500. So when I'm looking at my window and I went up to 10, that could be a problem. So just knowing about y1, you could say, well, I'll go up to 3,000 now. And I'm going to hit graph and see, does that make a difference? I didn't even consider my second equation yet, because sometimes you do that. You say, well, I know something about my first equation. I now can see the 2,500, which is the blue line. And fortunately, I can also see my second one, my y2, the red graph showing up there. Now, they don't intersect yet on this graph. And we're going to want to find out where those, when we type something into y1, and something into y2 and we're wanting to solve for it, we're looking for where they intersect. So from here, we could probably say, oh, I just need to change my x a little bit and I'd be able to see them intersect. But I want to talk about the red graph as well. The red graph is our second one. That's our exponential function. Does it make sense that our exponential function is swooping up to the right? Yes. Okay, that's what our exponential graphs do. Now, when t or x is 0, that's going to be your y-intercept. Does it make sense that our y-intercept would be at 1500? Because when x is 0, anything to the power of 0 would be 1. 1 times 1500. So this number out in front, your principal, which is the amount that you start with, makes sense that that's at time 0. Okay? So again, whenever we're looking at these equations, each of those numbers have meaning. And if we think about that meaning, we'll be able to understand the function better. So yes, we can see the 1500, we can see the 2500. They don't intersect yet. So I go to my window. I'm going to change my x max. I'm going to go to 20 because I think that's going to be more than enough to see if I can see where they intersect. And sure enough, they do on this graph. So now to solve this equation, we can go second, calculate, intersect number 5, enter on the first curve, enter on the second curve, enter again, and it comes to 12.83. Oh, and it was x in my equation there, but I'm using t here, so t is equal to 12.83 years. Now it said round to the nearest quarter of a year. Okay? I've seen in some places what the nearest quarter of a year is 12.75 years. I've also seen some textbooks say even though 12.75 is closer, you won't have hit $2,500 yet. So I've also seen some places where they would write 13 years. So which one is right? Sometimes you have to be, in this one I think they would accept both. To the nearest quarter of the year, sometimes the question will say, to the nearest quarter of the year, when will it first be over $2,500? And then the 13 years would be the right answer. So you have to be a little bit careful in the question.
Start with our grade 9 students for the region of the rebuttal cards. If we can have all grade 9 students.
And questions 12 and 13 are good to practice. We're going to do that right now, and you can start with 12, but I want everybody to do 13. 13 has like A, B, C, D, E, F. So we're going to have the first 3 people in this row do A, second 3 B, third 3 C, D, E, F.